Hello and welcome, everybody. This is a new series in our HPCC Systems podcasts. In this particular series, we are starting to cover some of the things that happened over the past 10 years, because in case you don't remember or you don't keep track of time, we are at the 10-year anniversary mark for HPC Systems open source. 10 years is a very long time, and I don't know, and I've seen so many open source projects coming and going those 10 years and any other 10 years period out there. That is really quite surprising that a project like this has not just stood the test of time, but also evolved and improved. But the project itself doesn't mean much if you don't consider those people that are involved in the project. All of those people that shaped this, that helped us build this platform originally, and then make it an open source project, which in itself is a big feat, but also shaped the evolution of this open source project. So many people in the community that has been driving innovation in HPCC, using HPCC, documenting, creating advocacy for it, teaching, giving examples, helping others. So there is so much there that we wanted to bring. I can't say that each and every one of those people, because this would be a very long series of podcasts, but at least some of those key people that have been involved in this project for a very long time, and to tell us a little bit about the story and to have a conversation about things that happen, what is coming, and how we fare those 10 years over the last decade. So for this series, we started with one person that has been core and absolutely key to this project, who is Arjuna Chala. And I think he needs no introduction. He's been with us for a very long time. He's been involved from even before the moment we open source, because he's been involved in this project when we were just thinking about potentially open sourcing the platform. So I think he's a great person to get this series started. And with that, welcome, Arjuna.
Thank you, Flavio. Yeah, it's great to join you in this conversation. And when this topic did come up last week, I really started looking back and seeing what we have achieved. And it's been a long road, but I think the things that we have accomplished is some of the things is really amazing, right? Considering that when we started, even then, during the Hadoop ecosystem progress and how the Hadoop ecosystem was evolving, HPCC was still new to people, right? And not many people knew what big data was about. And even now, even today, I see that people still lack the knowledge about what big data is, in the sense that they equate BI or data warehousing to big data in some ways or fashion. Yes, it is kind of big data, but it is not the core problem, right? And I think that is the challenge. That challenge was really magnified in the beginning, and that evolved to for us understanding what are the people really looking for. Whenever we go in front of an audience and talk to people about HPCC, there was always kind of a disconnect, because people did not understand what we were seeing as big data on our side, right?
Well, I remember, and this might show a flaw in the presenter, but I remember a presentation I did, which lasted for about an hour and a half, going through many aspects, technical aspects of HPCC and applications on HPCC. And at the end, one of the questions was, but then is HPCC like an FTP server? Which, so it means that it was quite far from many people at the time. But you're absolutely right. I remember now. It's amazing the things that happened back then. And yes, the Hadoop ecosystem was probably the closest people could get to any big data type of platform that was available to them. Right?
Yeah, and these new concepts, such as now they're referring to big data with data warehousing as data lake house, right? So they're coming up with these new concepts to basically explain where this fits in the architecture. And it is good, in a ways it is good, because now people are realizing it's not a direct fit of taking a data warehouse architecture and trying to force fit what we call as big data, right?
Well, but also the challenge, Arjuna, I think has been traditionally also terminology. When we came up with our own terms, none of these terms existed.
Yeah.
So when we had our original data lake, it wasn't called data lake, we called it data land. Yes. This is our data land system, and we still have systems within LexisNexis solutions called data land just because they were our original data land.
Exactly.
Now, when people came up with the term data lake, which is essentially exactly the same thing, it's just that you call it lake instead of land. Right. Now we started to think, oh, maybe they don't understand us because we are telling them about data land, and they really need to think about data lake. And we started changing those terms for other people to understand better. But yes, even terminology sometimes can be confusing if you are coming from outside and perhaps listening to other people talking about the same thing, but in different terms.
Exactly. And when I was looking at our historic roadmap, our focus has really been in solving the 80% problem, right? And I think that has been our challenge also, to selling the 80%, because there's no fizz showcase. It's all kind of ECL code centric. You're bringing in raw data, cleaning it, manipulating it, and then shaping it to a form that can be used down the stream. And that is kind of what we have learned through our LexisNexis experience over 20 years, that this is where most of the work is spent. And our focus has been even evolving the platform, from where it was when we released the 3.0 version. That is where I think we started.
Oh, I remember that. Oh, the good old times. Yes.
Right, and evolving it to 4.0, 5.0, I can see that we have put a lot of emphasis on making sure that 80% workload is efficiently done. And I think even now, even today, when we're moving to our new architecture, new designs with regard to moving it to Kubernetes, hot deployment, also elasticity around bringing up different sizes of the cluster on the same data. All that has evolved over time. It's not something that we suddenly decide, let's do this today and we can do it. If not for the progress that we made all throughout the year, past 10 years, it would have been almost nearly impossible for us to do what we're doing now.
But you know what? That aligns well with the philosophy we always had when it comes to data. This iterative exploration, this innovation. So you don't necessarily start with a well-known recipe or a plan with every step recorded there. You start by looking at the data and seeing what the data tells you, what you can do with the data. And of course, when it comes to the platform itself, that's also looking at, okay, what are the current needs? What is that people are looking for? What is that where can we push the envelope one more time, and then it's just go there, right? But that also, I think it's even applicable more generally, because even things that we have done throughout this decade, and some of those you and your group have driven. For example, when just a year ago, reality threw us a curveball and COVID-19 appeared there. Your group built all of this COVID-19 portal and all of the data analytics behind that portal, on top of a number of other things that were built as part of that particular ecosystem. And all of this was not something that was ever planned until that need appeared out there.
Yeah, absolutely. And it was such a natural fit to what we do in LexisNexis with regard to bringing something up like a COVID-19 platform for sharing data. Because ultimately, with regard to the challenges around bringing all the COVID-19 information together and providing a solution, it is a classic data lake problem, right?
Yes.
In a sense, you have many sources of data which we have to collate and clean, shape it, and then produce something that is very useful for the end user so that they can take some immediate action, right? And the whole intention for us for creating something like that is also to collaborate with universities like FAU, Oxford, Harvard, all these people who who really wanted to contribute in some ways, but they wanted to do it in agile and very quick manner, right?
Yeah.
And if we have the different architecture pieces for them to be able to come in and contribute that element where they need to, we can then pick it up in several different layers of the workflow and process it and bring out the richness in the user interface, right? And when that was our initial intent of setting up this COVID-19 data lake. It's more now, obviously, the user interface is quite famous. People are looking at the user interface because they can track that information very quickly. You can go to a particular country, look at what's going on with all the measures and some predictions. You can drill down to a state. You can look at that information, and you can drill down to a region or a county, and you can look at that information as well, right? So, and you can also play back over time how this disease has progressed from start to finish, which is extremely useful. But that is just maybe the 5% of the work that we have done. The core of the work is really what is happening behind the scenes in the HPCC with regard to getting all the data assets together, bringing it all nicely, collating it, fixing all the issues, and then producing the results on the other side, which is, as I said, it comes back to that 80% rule. And our focus has always been that when we produced this initially, people were like, Stan, how did you do it so quickly? Well, that is what we do, with HPCC and LexisNexis, over the 10 years, 15 years, 20 years, day in and day out. That's what we do. And the beauty of our platform is obviously that the main customer for HPCC is LexisNexis itself. And anything that we release out there as far as HPCC or the tools or ecosystem is concerned, that is definitely been vetted already by LexisNexis and tried by LexisNexis and used by LexisNexis. So the quality is there, right? And I think those are the key aspects, I would say, of why something like an HPCC system would be attractive to somebody else.
Yeah, having a very large, stable, and quality-oriented user is extremely important because it does give us this mirror to look at and ensures that whatever we release is both practical, usable, but also it has the quality that you need to be able to operate even a large corporation. So it's,
I remember, before, this goes back to the experience before LexisNexis acquired ChoicePoint. That was the original company.
Oh yeah, that's
I am from, right? And I remember the way we solve big data in ChoicePoint is entirely different from how HPCC solves big data. We stood up Sybase database of multiple nodes and then pushed the data. And basically what we were trying to do is trying to do what HPCC does, but using a database technology, divide and conquer, but divide and conquer across maybe 50 Sybase server nodes, database nodes, right? And the what was really
well, it's so sorry to interrupt you there, Arjuna, but that's a great point. So when someone asks me, what is the big advantage of using HPCC over anything else? We can apply divide and conquer using databases, but it is the abstraction layer. It's
Yes.
seeing all of that data as a one thing, being able to code something. Let me code a filter or a sort or any other big data process as if I'm dealing with the entire data set or the entire set of data sets without needing to think of, how is this distributed in the database? Oh, this is partitioned in this particular way. Oh, no, I don't have the piece that I need for the joins. So now I need to redistribute the data. All of that is done for you. And you have this very succinct high-level language CL that gives you this abstraction layer. This eliminates all of the needs to be dealing with individual systems, individual databases, and all that. Yeah, I can imagine that if you try to do this with Sybase or Oracle or whatever you tried in the past, this would have been unsuccessful. There is no way to do that efficiently.
Yeah, absolutely. And to keep up that operation, with regard to maintaining those servers, the database servers, and maintaining that, we had a team of 50 people. Just to troubleshoot issues. Obviously, with that particular architecture and design, there's always going to be issues, right? We were trying to force fit a technology into doing something that is not really meant to do. And it was on a daily basis, fires and trying to fix issues and all that. But what was really stunning to me is when we came into LexisNexis. Okay, I was thinking LexisNexis with the HPCC operations team, they're going to have hundreds of people because the size of the data is much more larger, complexity is larger, everything was larger. You're running 10,000 plus nodes of HPCC and all that. But when I realized there's only 2 people actually supporting and operating these HPCC clusters, that was really what in me made me realize this is something special. Now, this is not something that is out there, and that is probably not going to be out there in our competition world, in anytime soon. And at that time itself, it was the realization, and that's why coming on board to the open source ecosystem and why we try to open source is to stay relevant and all that was much more easier, right? As soon as we realized that, then we could get on board and support each other in making sure not only just we benefit from it, but why not the outside people benefit from it, right?
Well, and that's there's a theme there. The same applies to the COVID-19 project. So it is to do as much as we can to benefit humanity, and the same thing applies to open source. In general, I've been always a big consumer of open source, and as I could, I gave back to the open source communities by either building some projects or helping with other projects, or even returning some contributions to the open source community. I think that's the beauty of it. But of course, in order to be able to be effective, people that are involved, they need to be convinced that that is the right thing to do.
Absolutely, absolutely. And I think the process of evolving one step at a time is fairly important because if you look at I was looking back and looking at our 6.0 release, and that's when we started supporting the multi-channel support on Tor. We had reworked our memory management on Tor to make it much more efficient. And the reason why we were doing it is slowly but surely we were comparing ourselves to something like Spark on the other side. We were running benchmarks constantly and making sure we always perform better than our competition in those areas. And once we realized, we will hit a bottleneck at some point in time, we were making adjustments to get ahead of that curve and stay ahead by making this adjustment. And if we had not done it at that time, if you try to do it now and try to move it to Kubernetes at this point in time, it would have been a near impossible task, right?
You're right. Well, if you keep abreast of technology change, if you tend to stay in the lead, it is far easier to take the new changes, the new challenges, the new leads, because the delta is relatively small. Okay, we are already here. Going to the next one is not that far. If you stay behind, and then you need to suddenly introduce a significant amount of changes to get to the lead, that's almost impossible. You just can't do it. It's
Do you remember our first machine learning libraries?
I do. Oh wow, that's absolutely yes.
Yeah. Again, it comes back to the evolution, process, right?
Absolutely, yes.
Yeah. So I remember, it worked, but it did not work on big data, the very first version, right? And we soon realized if we do not do the engineering at the foundational level of distributing the mathematics or the arithmetic around building those models, then we are going to run into issues at the top level, which was very, very difficult task. I don't think many people outside of HPC has even conquered that, right?
Well, the issue there is, if you ask me, I think we were thinking in a way that was far too abstract. And abstraction pays a price in performance. That's inevitable, right? The more abstraction you have, the further away you are from the hardware, the more performance hit that you're going to take. So finding that nice balance between abstraction and performance took some time and experience and playing with it. Yeah. We came a long way from there.
Yeah, exactly. And now embedding TensorFlow within the platform itself, I think it's been around from the 7.0 release, makes it even more powerful just because now you have all those feature-rich functions that are available in TensorFlow. Now also you can use that in ECL, right? And also, one of the, I think, key advancements that we did was building that pluggable interface so that we can plug in other languages a while back, right? Supporting whether it's Java or Python or R. Now when we go back and try to execute some of those workloads in Python via the TensorFlow interface, that makes it so much more easier, right?
Yeah, that is absolutely true. Yes, yeah. Now that you're saying that, I'm thinking, well, should we also support transpilers and allow for people to code in TypeScript and embed JavaScript coming from TypeScript?
Yeah, that's a good question, and I think we are kind of on the path to do that with two aspects. One is the new HSQL language, which is kind of an abstraction.
Very good point. Yes. Yeah.
Okay. And we are providing full semantics of what SQL can do. But again, we don't want to propagate to the whole audience, right? There is a usage for using something like SQL versus ECL. ECL is extremely good for processing ETL type of workflows. I've seen many people that have come in and been successful in ECL, and when they go out and they're exposed to something else, they always come back to ECL, mainly because the semantics of how a data flow works is built into the ECL programming language. If you look at working it with one record at a time, like the project, then two records at a time with iterate. It's just the patterns of data processing is built into the ECL programming language. Right.
Well, and I think that's absolutely key. You are something there. The fact that the language is capturing those concepts and is expressing them as primitives in the language is absolutely paramount. You wouldn't be able to do the same things that you're doing without a lot more work if that wasn't the case, right? If you are trying to go and express those with SQL, and then you will find yourself creating a massive piece of code that is probably inefficient, clunky, and difficult to then debug or understand later on, right?
Yeah.
Even if it works.
Yeah, absolutely. And what we realize is we should cater to different audiences, obviously. So, ECL is probably not for everybody. If you're not into the world of performing data shaping or ETL, then there might be some other way to actually solve the problem. And that is why we're introducing SQL as an abstraction, so that people, even to execute like machine learning workloads, they can use SQL in that fashion, just like how you do it with like Spark SQL. But this is even better because you have only SQL semantics that you can code directly within your coding IDE like VS Code or ECL Cloud IDE. You don't have to mix your Python code and then embed SQL within that code like what.
But you can still leverage the ECL code for your 80% of the work, which has to do with all that data shaping, all of that preparation. So you get the big lift from the ECL work that it's been done before that, and all you need to do now is just implement a specific method for your machine learning problem or something else. But you still get all of that lift, which if you were trying to do that from scratch, I'm going to get the data in right now, and then I'm going to shape the data using SQL. I'm going to join the data set with other data sets using SQL. I'm going to do all of the filtering and transformation using SQL. I don't know. That would be, I think, a lot more work.
Yeah, and a classic example of this is when we were speaking to DataSeers in the beginning, right? They had this vision of, well, let me bring in this nice commercial in-memory SQL engine and it'll solve all my problem. But when I looked at their use case, it was almost like the classic funnel diagram that we have in LexisNexis, right? Here on the large part of the funnel, you have all these data sources and that you're going and acquiring data from and bringing that in, shaping the data, cleaning the data, and then producing the analytics on the other side, right? And if you look at their banking problem, they were looking at thousands of sources themselves where people were sending transaction data, account data, all this information, and it was funneling that and making sense of the data, collating it, and bringing it all together was 80% of their problem. And it took a little bit of convincing, but once they did it, it was like an amazing solution for them, right? For that particular bank, I think the job used to take like literally 10 days to ran like less than half an hour, right? Something like that.
That's amazing. Yeah. And to make just to make it more interesting, this is not the only case. We have so many cases where people have told us, "Oh, I used to run this in 3 days, and now I can run it in 50 minutes." Or I used to run this in a week, and now I can run it in a couple hours. That's just I see that case on and on. Every time someone comes from the outside, they are absolutely surprised that now things that they used to take a lot of time and also a lot of work to keep running. In many cases, they were running something that wasn't even reliable, so it broke continuously. And now they had a reliable process that could run on HPCC and do the same exact thing, but in a small fraction of the time.
Yeah. I mean, I think there's some great things that is coming in the pipeline with regard to HPCC and the whole. I wouldn't say redesign, but our whole evolvement of our architecture to being cloud native is going to be extremely important in the next 3 months or so. And I think we have the 8.0s release scheduled to go in the Q1. But to complement that, we also are working with a data curation and governance system called Tombolo, right? And that is where I think the audience will need to understand, the potential customers will need to understand. It is one thing to bring in all these data assets into your data lake, but if you lose track of what these data assets are, then you lose track of your business intelligence on the other side. And you run into several problems, and one of the major problems is regulation, right? And if you're not...
Well, it is the distinction between data integration, data management, and data governance. Yes, surely HPC has traditionally done very well data integration. It has been a data management-centric platform forever. But perhaps the data governance piece, if you don't do this natively in HPCC, you are now forced to integrate in an external system to feed from HPCC back and forth and control how the data is processed, which is a little bit hard to implement. So that's, I think, what Tombolo brings to the table.
Yeah, and I think the whole concept of the other thing that I run into when I'm speaking to people in the industry is, why not just use this enterprise data governance tool that is already available? Why don't we just plug it into like something like an HPCC? But it's not as straightforward as that, right? Because if you do not control the curation of the work, and you're just giving them the data dictionary is only useful to a certain extent, right? You really want to give them the 360-degree view of how the actual workflow is working.
Exactly.
Who's giving the data? Who wants the data? How is this data evolving to the next stage? Who gave you permission to make that happen? All that, right?
You need this sort of executable document. It's a document that is automatically fed from what the reality is and that can apply automatically those constraints that your governance process has to the reality. Having a document that tells you what the ideal situation is, but has no connection with what is being actually done, it doesn't give you much, really.
Yes. And the thing, we LexisNexis, we have experience with that, just because we have a more proprietary internal system, obviously, that we needed to develop way back, correct? And we know how that system is important to satisfying regulators and in-house people who are looking at how this data is evolving. What we are trying to do now is try to use that experience and bring that into this open source tool, Tombolo, so that everybody else in the enterprise world can leverage that if they're going to use HPCC. Obviously, this is very closely aligned with what HPCC is doing. It's not a generic tool that will work for any other data sets, but more specific to HPCC because it needs to know what the curation is for it to be able to do the governance. So it's all tied together.
Hey, Arjuna, with that, I think we just ran out of our allotted time. So thank you very much. This is a great conversation. I think we need to continue this conversation in another episode.
I think it was a great journey. So,
It
the
was,
last
absolutely.
10 years has been fantastic. And I think it's going to be really good this year, especially with the cloud native support that we are going to provide and all the tools that are coming in the pipeline. Thank you, Flavio.
Thank you very much, and happy 10 years, HPCC.
Happy 10 years to you too.